Sorry, I meant to say 87. Go to page 87. Adding and subtracting values with their uncertainties. This might already show up on an AC tomorrow, so I will hold back on the AC I was going to give you. So some of the stuff we did yesterday will show up, as well as this. So adding and subtracting values with uncertainty. Okay. When adding or subtracting measurements, they each have an uncertainty. So the combined value will also have an uncertainty. Okay. The uncertainty of the final amount is the sum of the measured uncertainties. What? It's called combined uncertainty. Combined uncertainty. So if you're for example, if you're administering COVID vaccines and they have the vial, right? Every time a nurse takes out a little bit out of that vial, there's a bit of uncertainty there, right? Like you're taking out 5 mil, let's say, but it could be 4.5 or 5.5 mils, right? Like we don't know exactly. So that amount keeps on adding up. So whether you take stuff away or whether you add, there's an uncertainty that keeps building up. Okay. So here's the another important topic here. Note. Okay. If you weigh a number of items separately, right? The combined uncertainty will be greater than weighing all items at once. Okay, so if you're an airplane, if you're the person taking on the luggage, normally every person drops off the luggage individually and they weigh every item individually and then it goes on. But you know what? They actually probably weigh all of them or a bunch of them at a time just before they load the plane. They just want to make sure you're not surpassing your limit, but they don't add up all those weights and then know what's on the plane. They all go on a pallet or whatever on a crate, and that crate gets weighed, and then they know the combined weight, right, all at once. So let's explore this a little bit. Marcy, sorry, I wrote this before you were in my class. Okay, so it's coincidence. Marcy is a carpenter. She's installing sheets of plywood as subflooring on a balcony. She has measured two of the sheets to be, there's two sheets, right? One is 2.25 meters and the other one is 1.30 meters long, using a tape measure marked in centimeters. What does that tell us? That gives us the precision. Precision is 1 centimeter. Boom, right there. A, write the lengths of each plywood in the form measured value plus or minus uncertainty. Okay, so that's what they're asking us to do. So we're gonna go, I want to use this space here. So I'm thinking board 1, okay. Board 1, we're gonna go, let's just backtrack a little bit. We need just 1 second. We need our uncertainty, right? What's our uncertainty based on this? 1 centimeter divided by 2. This is on page 87, guys. We need to have our uncertainty. We got it from this little statement that gave us the precision, that gave us the uncertainty. Be very careful, because you know I show you sometimes you get your precision from the measurement, but in this case, we go by what it says here, marked in centimeters. That's what gave us our precision. So board number 1 is 2.25 meters plus or minus 0.5 of a centimeter. Okay. Board 2 is 1.30 plus or minus. They both have the same uncertainty because the same tape measure was used, so we used both of those uncertainties. So this is answering A. We wrote both of the measurements of both boards with their respective uncertainties. Okay. Imagine for a moment this had not been here. Just look up here. Let's say this whole part would have been scratched off. No markings at all. Then you got to go back to the measurement and get your precision from it. Okay. In this case, they did say that this trumps everything. I shouldn't be using that word, right? Still, can get in trouble for that. What is the total length? The total length, including the uncertainty, of the 2 sheets if they're placed end to end. Okay, if they're placed end to end. So let's make a little diagram here. The first board is, let's say the first board is 2.25 meters plus or minus 0.5 of a centimeter. This is board 1. And then you put the next one right beside it, and that one is shorter, right? You know what? I'm going to redo this bottom part because I want them both to be under their boards. Sorry. Let's try this again. 2.25 meters plus or minus 0.5 of a centimeter. And you're like, Mr. Grayson, there's centimeters and meters. That's bizarre. No, it's okay. You can do that. And then the second board is 1.30 meters plus or minus 0.5 of a centimeter. So you're putting them side by side, end to end. Okay? So we want to know what is the combined length of these sheets if you were to put them end to end. Like, what is this here? That's the question mark. So watch what you do. This is how I show it. 2.25 meters plus or minus whatever the uncertainty is. And then you take the next board plus or minus whatever the uncertainty is. In this case, they happen to be the same. Okay? So you add it up. You can use your calculator or you can use the good old-fashioned mental math. Plus or minus. What's 0.5 plus 0.5? Duh, right? 1 centimeter. I tend to go like this. 1.0, I stay with the centimeters. Okay, so this is what the combined length would be. And this is the combined uncertainty. Let's wave this like that. This would be the combined uncertainty. Okay. And so we always add up. Let's say there had been 4 boards. You keep every single one of those uncertainties gets added together. If you put 4 boards end to end, we would have 4 things adding, and we would combine those uncertainties, right? There would have been 2 centimeters, right? Half, 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 and so forth. So, and the uncertainty can vary greatly. This could have been 0.25 or whatever it is, we just add them up, right? And we'll do another example here where it's subtracting, but we still add the uncertainties, okay? Okay, let's do the next one, and then I'll give you tests. Junior has a bucket of water with, right, the bucket has 20.5 liters. He needs to draw some water for some plants using a smaller jug that can hold 1.2 liters. If Junior draws, right, 3 jugs from the big bucket, determine how much water will be left in the bucket, including the uncertainty. Let's just do A for now. Don't worry about B. It's not that complicated as long as you do it step by step, right? So let's do this. The bucket, look at that. Look at that bucket. Okay? It's as good as it gets. It has 20.5 liters in it, like sitting in it, water in it, right? I would, in this unit, okay, are there any markings? Do they tell us what the markings are on that bucket at all or anything like that? No, so we need to go by the measurement. What's the precision of this bucket? 0.1, 0.1 of a liter. Therefore, what's my uncertainty? Half of it. You probably have seen the pattern that if you split something that's with 1 in half, you end up with a 5, right? Okay. Let's do the smaller jug. I don't know, this one is going to be, I'm just going to put a handle on it like that. And this one can hold 1.2 liters. Right? And my precision, would you say the precision and uncertainty is the same? Precision and uncertainty is the same because look, they both have 1, so 0.1 liter. Uncertainty is 0.05 of a liter. So they happen to have, guys, they happen to have, I didn't want to throw an example in there where they have different uncertainties. They happen to have the same. We're very happy about that, okay? It makes life a lot easier. So when you have this written down, I've done this on the side, sort of, it's like a side note. I do that first. Let's start with our 20.5 liters, and it has an uncertainty of 0.05 of a liter, correct? And when you draw from it, obviously you're subtracting. So we subtract 1 jug, and it has an uncertainty. Then we subtract another jug from it, plus or minus. The uncertainty doesn't change, right? The jug keeps the same uncertainty. And our third jug, another 0.5 of a liter. So minus, minus, minus. So if you had 5 jugs, some of you might be thinking, Mr. Erickson, why don't you just multiply it by 3? Like, why do you go through all that trouble, right? Well, I like it to be very visible. So watch this. This is gonna probably be a bit counterintuitive. This is counterintuitive. We subtract here, and this is the controversial part, but we add all of the uncertainties combined. We add them up. Every time uncertainties get added, okay? And so let's do this. I actually have the answer key, but I will walk you through it, right? So if you want to do it this way, that's 16.9 liters, like left in that big bucket, plus or minus. I'm going to cheat here. I'm going to go 0.05 times 4 instead of adding it 4 times. So my combined uncertainty is 0.2. Okay? And this is what the question is asking for, leftover. And this is the combined, right? This is the combined uncertainty. And the reason being is when you bring things together, whether you're subtracting or you're adding to it, their uncertainties keep adding up. And the more you mess around with stuff, the more of an uncertainty there is. So it's better to actually just get one big bucket and just take like 3.6 liters at once than to take 1.2 3 times, right? If you have the choice. So I'm just gonna add this and we'll have enough time for the test, okay? I want you to know that for B, what's the maximum that could possibly be in that bucket? Maximum left over. 16.9 plus 0.2. So that would be 17.1 liters is the most that could be in there. The most that could be in the bucket. Right? That I'm just focusing on the max. Like I just went this plus the uncertainty. Like you're saying, hey, we could have more or less this much in there on top of the 16.9. So I went 16.9 plus 0.2, and that's that. So will Junior have enough water for that 17.5 liters? Nope, there's not enough. Even if you went with the maximum that could possibly be in there. Therefore, Junior will not have enough water. I'm going to box this in separately because it kind of answers that second part. I will say this. If you go to, I think it's page 15. Page 15 in the workbook. If you want more of this kind of stuff, I will post the key. Okay. There's more of this kind of stuff, and there's not one example that is the same as the other.